In this video, we'll discuss how to solve exponential and log equations using some strategies also from section 3.4. So we'll start with exponential equations. Here are some strategies that would be useful for us. For example, if you can bring both sides to the same base, then you don't need the logarithms. You can just solve them basically as they are. Or you can also, if you cannot do that in step 1, then you can convert exponential form into log form. That's usually useful when the variable is on one side of the equation and then you have a constant on the other. You can turn it to the log and solve for the x, for example, in the exponent. Or here's another useful strategy. You can take a ln of both sides or a log of both sides, and that's especially useful if you have a variable on both sides of equation. So sometimes it would be more complicated to do it otherwise. For example, if we have this equation, 2 to the power of x is equal to 16, well, note here we can bring it to the same base. 16 is a power of 2, it's the fourth power, which means the x would be 4. Okay, and the solution is 4. And then we can have 8 to the power of x equals to 32. It's not apparently obvious at the first sight. 32 is not a power of 8, but they can both be reduced to the power of 2, and we can use some properties of exponents. For example, 8 is a 2 to the third power of x equals to 2 to the fifth power for 32. Here we can use the property of the exponents where we multiply the exponents. It's this one. And then we can just solve it as an equation. So basically, if the bases are the same, the exponents are the same also. They do not quite cancel, it's just that they're equal. And so we have 3x equals 5, so x is 5/3, and that's the solution. Now, what if we have an equation like 2 to the power of x equals to 3? We've seen this earlier, but we cannot use the same strategy. Well, here is, because as x is the exponent, you can convert it into logarithms. For example, it's a log base 2 of 3, and you can either use that setting on your calculator, which is again alpha window or math, option A, or you can use change of base. You can write it as log of 3 divided by log of 2, for example, and that's what I did. Or actually, I did it with ln, and we get 1.585. And then there is a more direct approach where we can take a ln of both sides. Notice how we can put the x down. So x is ln of 3 over ln of 2. Now, let's take a look at this equation. 2 to the power of 2x plus 3 equals to 15. Here we'll just keep on using the same strategy. What if we take a ln of both sides? Again, a ln is mostly a preference thing. You could use any log, or you can just use log base 10. Usually I use log base 10 or ln because they're easier to put in the calculator. Or with ln, they're also useful with e a little bit later, so it's just a preference again. So if we do this, take a line of both sides, notice how 2x plus 3 comes on the front. Just like in the original equation with the x, we use the property here of the logarithms, where a ln of any 2 to the power, it can just come on the front and become a coefficient. That was one of the properties we discussed last time. So in that case, in the previous case, it was just x times the ln of 2, where we could just divide. And here, I usually prefer to distribute first. That's how we avoid complex fractions. So you can distribute a ln of 2. It's like a constant. So you'll get 2x times a ln of 2 plus 3, a ln of 2 equals to a ln of 15. Then you can isolate the term with the x by subtracting 3 a ln of 2. You cannot combine the ln, so usually I typically write them like this. That's how we get the exact expression, a ln of 15 minus 3 a ln of 2 over 2 ln of 2. So I divided by 2 ln of 2 for both sides. So to put in a calculator, I usually put the top in parentheses. This is how you would do it at once. Don't forget to close the 2 parentheses and then for 1 for the top. Divided by, again, put the whole bottom in parentheses, 2 times ln of 2. If you do not do that, then the order of operations may be different and you may get a different answer. So I'm getting 0.453. And here's one where the x is on both sides. Similar option works if you take a ln of both sides, and you can pull the exponents down in the front. Same idea, you may want to distribute a line of 2, which will be a line of 2 minus x ln of 2, and on the other side we'll get 4x ln of 3 plus 6 ln of 3. Then we'll combine all the x terms on one side. I just basically added x ln of 2 to both sides. And you can also subtract 6 ln of 3 from both sides to get that. So then, if once you have all the x's on one side, you can factor it out. Then you can divide by the remaining expression. So we get this. This is the exact answer, basically. And again, you can put in the calculator using parentheses. And what I got was negative 1.160 to 3 decimal places. Okay? Now, on to log equations. Usually, typically, if you just have a log of a base of x equals to a number, you can transform it into exponential. So if you start with a log, transform it to exponential, and sometimes you remember we can do the same thing with exponential, so turn it to the log. So it works both ways. Now, if more than one log is present, then you may have to use properties of logarithms to rewrite it as a single log. Okay? So let's say if we solve something like ln of x equals to 0, you may suspect what the x would be, but let's rewrite it as an exponential. It would be base e to the power or exponent 0 equals to x. Well, what do we get then? We get 1. So if you recall, ln of 1 would give us 0. So the solution is 1. What about log base 2 of x equals to negative 1? Same idea. You can write it as base 2 to the exponent negative 1 equals to x. So we'll get x is 1/2, basically, or 1 over 2. Okay. What if we have 3 plus log of 2x plus 5 equals to 2? Well, let's work on isolating the log and have it all by itself. So we can subtract 3 from both sides. We'll have it equal to negative 1. And then again, notice how there is no base, but that means generally that it's base 10 to the negative 1 power equals to 2x plus 5. So we'll get 1 over 10 equals to 2x plus 5. Now we must use fractions. So it's 1 over 10 minus 5, or 1 over 10 minus 50 over 10, which will get negative 49 over, I think it should be 10. I think there's a minor typo here. Let me fix this. It's literally, it should be 10 as the same denominator. So I'll just put 10, and that's equals to 2x. So if you divide by 2, that shouldn't be 100, it should be 20. So negative 49 over 20. So make a note of the typo. Okay, so if we divide, yep. Okay, then if we have a log, let's say, of something more complicated, even with a quadratic equation, x squared minus x minus 5 is equal to 0. Then we have, again, 10 to the 0 exponent equals to x squared minus x minus 5. That becomes a 1. If we recall with quadratic equations, we must set it equal to 0. So we subtract 1 from both sides. And then you can factor. Now be careful whenever you factor, you may want to watch for the signs. It's not just the negative numbers, but when you plug them back in, make sure you don't get a log of the negative number because it would not be defined. Now in this case, I don't think it should be an issue. It's usually an issue if you have more than one logarithm and you try to combine them. So 3 and negative 2, I think both of them is going to give you 1, I believe, because it's 9 minus 3, that's 6 minus 5 is 1, and then negative 2 squared is positive 4, minus a negative 2, that's positive 6, and then minus 5 is 1. So both of them work out, so you'll get 2 solutions here. So generally, I recommend check the solutions. So we get 3 and negative 2. And here is one where not everything may work, but you have the couple of logs here. Again, we can combine them because of the plus. Can make them into single log with multiplication. And then we can turn it to the exponential. So again, usually this strategy, turning it into exponential equation, works. So let's say it would be 10 to the 1 power equals to x times x plus 9. We distribute it, put it on the other side, so we factor it, and I get x plus 10 times x minus 1. They multiply to negative 10, add to positive 9, so that works. So you get 2 solutions again, negative 10 and 1. Well, 1 would work okay. Log of 1 is 0, and then log of 1 plus 9, that's log of 10, which would give us 1, so that works. But negative 10, however, log of negative 10 would not be defined, and then negative 10 plus 9, that would be log of negative 1. Both logs would not be defined. Even if one of them is not defined, that doesn't work already. So we have to cross out negative 10 and only keep 1 as the answer. So that generally happens when you have more than one log. And just don't think it's only negative numbers that would give you negative. Once in a while, it's also positive numbers that may give you a negative in the original equation. So you have to be careful generally whenever you have more than one log. Make sure plug it back in and check for negative numbers back in the original equation, not so much in the beginning. Okay? And that's it for this section.